Hello everybody, today in this video I'm going to show you how to create your own high-resolution map on JavaScript without third-party libraries. This map supports features like pan, zoom to the cursor, and supports several layers. Uh, and because of these layers, your map works without any lags, without any performance issues. So uh, we already have some implementation of this map. For example, UESP project implement this map. I didn't find any repository for this map. I don't know what they use under the hood, what technology they use, what third-party libraries, but it looks cool. In general, it looks cool. You also can see here towns on the top. When you zoom out, uh, you see less, I would say, locations. If you zoom in, you see more locations on the map, just like in Google Map. Uh, it uses the same techniques with layers. It has 4 layers. When you zoom out, there is a first layer with a low quality. When you zoom in, next layer is downloaded. Download only those styles that are visible in the viewport. This way, you have very good performance of navigating on this map. So, and of course you have additional features, but now it's not the point. We're not in this video, we're not considering how to put on the top additional signs, additional text, etc. But it's because it's not too complicated. The most complicated part is just create zoomable map, that high resolution map that works quite smoothly with different layers. So a next implementation of this map, it's custom implementation. It works much better. It has more features inside, so you can, for example, turn on and turn off some locations. I found repository for this map. It's called MW map, and the main third-party package developer uses is Canvas. Node Canvas is their Canvas implementation for Node.js. And I download this repository, I run it myself, and to be honest, it was quite tricky to install this additional third-party packages on Windows. It required additional tools and etc. So I consider this package as a third-party package. In my solution, I'm going to use also Canvas, but not as a third-party package like that, but Canvas in HTML and operate with this Canvas in TypeScript code. So I won't use any other third-party libraries. Here is my solution. You see, it also works smoothly, and there is a couple of rectangles that I'm considered have to be some mines or cities or something like that. I just put it on the top for test, but don't focus on it much. So let me show how it works in Network tab. So first of all, when you open the page, it downloads 4 images. This low resolution layer has 4 images, low resolution images. Once you zoom in, okay, let's clean up this network tab. Once you zoom in, it downloads, okay, it downloads next images for the second layer. And when you pan, when you're on the second layer, you will be automatically, or new images will automatically download it as you pan the map. So let's zoom again on the third level. And you see on the third level, we again downloaded some images with even has bigger, twice bigger than the previous layer and with higher quality. And the last layer, fourth layer, again, we download uh, even more quality images, and only those images that are visible in viewport. Uh, to be honest, there are a lot of libraries, Zoom and Pen libraries all over the internet, and they works good. But the problem with those libraries, for Angular at least, that they don't support layers. They don't support if you put high resolution picture in this component and start resizing it. So browser will consume a lot of CPU, and every time you zoom in, you have to wait for several seconds, and it's quite annoying. Uh, so that's why I don't use this library, and I implement my own solution that will support and zoom and pan and several layers with different quality without any third-party packages. And it took me about 150 lines of TypeScript, one line in HTML, and 20 lines in CSS. So not really big application. I would say it's just one file. You can, uh, if you don't like Angular framework, you can do the same in React.js or even Vanilla.js. It's not a big deal. I use Angular because it's more convenient framework for me. Okay, let's start. As a first step, I'm going to create image in a canvas. For that, I need to download some images for the maps. I took these images from previous project and download this special script they call it download.js. This script download all the layers, all the images, and put in a special folders. Let me run the script. I already ran it before, so let me run it again to demonstrate how images are downloaded. In folder assets, you see new created folders for 4 layers. First layer contains 4 images, second layer contains 16 images, and etc. And now we have all layers for our application to display this map. And as a first step, I want to display that image. Assume take image from the third layer, image 4 and 4. This image I wanted to display in the browser. What I have to do for that? First of all, I need to clean up the HTML code and put here canvas code only. I put here canvas. And also I mark this element with special hashtag in order to Angular can recognize it. In CSS code, I put some styles for that canvas. Let's stretch it to the full screen and add some background. In general styles, I also add the HTML body styles, and that's it. Now we have styles. Let's let's try to run this application and see what we have. Okay, we have our application up and running, and you see this is a background of canvas. What we do next, we want to create a reference to this canvas inside the application, and we do it with special thing that's called an Angular view child that return our element reference. So now we have to initialize our canvas and context, add lifecycle hooks, add lifecycle hook ng on init. Okay. So after that, to now we have canvas variable and we have context. So what we do next, we set height and width for canvas sizes. We create an image. Let's define an image. Image is a HTML element, and we kind of want to create new image. New image. New image. So we have a new image, and now we have to put it inside. We have to specify source code for this image. This image src. Okay, this image 4.4. Oh, sorry, 4.4 and WebP format. Okay, we set src, and now this image, and we have to specify callback on a load because we cannot just draw this image in a canvas because it won't display anything. We have to draw this image after it's loading. Once we specify this src, when the time we specify a source, it should start loading. So now we have to wait for loading, and image on load. So we have to specify. Let's do it as arrow function, and we have to put images in context, in canvas context. Draw image, and we have to set coordinates. Let's say we have set initial coordinates for that image. Okay, let's see what's happening. Nothing happened, right? Okay, the problem is that image not found. Huh, okay. WebP. Okay, typo. It's just typo. Okay, and here we have the image. So now we can commit this result as a step one. Does everything, and also we can commit downloading script. We're not going to commit these images. We don't want to keep it in the repository. You can run download script yourself and download the images yourself, or even specify the full URL to this image. But I highly recommend to download images first. And then commit as a first step. Okay. And now we can move on with second step. On the second step, we're going to drag our picture. In order to do this, we have to add several variables in our class, several attributes in our class, and 3 event listeners. These attributes will be flag is dragging. It indicates whether we drag picture or not. By default, it's false. It's drag start variable that indicates the position when we start dragging. And also we need to add camera offset. It is the offset of camera when we're looking on the picture. So if the picture is moving forward, the offset is changing. So this offset we need to set a different coordinate for this picture. So let it be x0 and y0. Okay, well good. We have all attributes we need. Now we have to add some listeners. First listener is mouse down. So every time we put mouse down, we set is dragging flag to true, and we calculate drag start coordinates according to our mouse position according to current offset. So when we uh, put mouse up, we set drag false, and this is all what we need on mouse up. The more interesting thing happens when we move the mouse, and when we move the mouse, so okay, let's remove it. It's not, we don't need it right now. So when we move the mouse, we change offset according to current coordinates and the start dragging position. So let's see what's happening now. No, nothing happens, right? Of course, nothing happens because I don't update the picture. So in order to make it right, we create a draw function, draw, and put here our draw images, draw image, and also instead of draw images in ng on init, we call function draw, this draw. Okay. When we start the application, the image is loading, but when it's loaded, we don't need it load again. So we have to check every time we redraw the image, we have to check is it loading or not, is it loaded already or not, and for that purpose we have a um, special attribute called complete. If this image uh, completes, if this image complete, then we just then they just draw it without waiting when it's loaded. Uh, otherwise, otherwise we are waiting for it. So this is a logic is required. So okay, let's see. Okay, our picture still here. We actually can try to do this. For example, if we put draw here, for example, in every function, let's see what's happened if we put draw function in every uh, on mouse move. Actually, we need only on mouse move. Okay, if it's dragging, blah blah blah. Okay, and put here. Call this function. What's happened? Nothing happened. Okay, nothing happened because it's zero coordinates here, and we need camera offset here. Actually, this camera offset x. Oh, we need to change our image coordinates, our image offset. So we have to put variable that is changing during move. This camera offset. Okay, good. Okay, now we see we can move our image, but we still have some artifact on the background. So we have to clean up our canvas, kind of. Let's put it here. Okay, let's restart the application, and now you can move this. You can move this map with the mouse. What else we need to add? We need to add some special class because you see this hand is not grabbing. When I click the mouse, we need to change the cursor. When I release the mouse, we have to change cursor back.
So in order to do that, I will add special style. It's called add special class is dragging the equal is dragging. So when it's dragging, I will have class is dragging. Let's do it in that way. Is dragging. Okay. And in CSS, put it like that. Canvas is dragging and cursor grabbing. Let's see what's happened. Let's check. And you see, when you click mouse, cursor is changing. Now I grab the picture. So I need to commit this as a second step. Second step. Let's commit. Now we can move into third step. On the third step, we add zooming. So what we need for that? For first of all, we need zoom level. Zoom level equals 0. Every time you scroll mouse, zoom level should be incremented or decremented, and you expect the image change it in size twice, for example. It depends of zoom factor. Okay, let's add some constant. Sorry, constant zoom factor. Let it be 2. So if you zoom in, you expect picture to increase in size 2 times. When you decrease zoom level, you expect the picture decrease, um, become twice smaller. Next constant, we need that max and minimum zoom. Let it be 5 and -5. And also we need, because you cannot endlessly zooming in and out, you have to have some range of zooming. And one more constant we need is tile size. Tile size is actually original. Okay, let it call it original. Original. Original tile size. Oh my god. Oh my god. Original tile size equal 2048. All the tiles for all the layers will be the same original tile size. So we have zoom level, we have a zoom factor, and having zoom level and zoom factor, now we can calculate camera zoom. That will be, we have to take, in order to calculate, we will need to take zoom factor and raise it in power level, zoom level. So we needed camera zoom. We needed to. It doesn't matter what zoom level you have. Every time you zoom, it should looks like you are zooming with the same speed. On each level, on every level, you have to zoom with the same speed, back and forth. Okay, we have camera zoom. So now we need event listener for scrolling. And in this event listener, we have to calculate first zoom direction. Zoom direction that um, zoom direction we just take sign of We just take sign of event zoom delta, event event delta. I prefer inverted zoom, so you see minus here. But what direction we're zooming? Zoom in or zoom out? Now we have to check is our zoom is maximum or minimum, so we can if we exceed maximum zoom or less than minimum zoom, we just exit the function without doing nothing. Well, same. For that we need zoom delta is zoom level plus zoom direction more than maximum zoom, or this zoom level plus zoom direction less than minimum zoom. Just enter, return. Otherwise, this zoom level equals zoom direction. Increase change zoom level, just zoom level to zoom direction. Okay, so now we have zoom level. Now, uh, now what we needed to calculate camera zoom. Yes, it's camera zoom. Actually, we use the same formula that we used in the beginning. Camera zoom, yeah. And after the finish, we call draw. Okay, let it be. That should be enough, I think. Okay, what we do in function draw, in function draw, we need to scale the image. But the problem is if we can scale the canvas context, but the problem is when we scale canvas context, we also need to recalculate our camera offset. Instead of scaling the context, we are going to scale image itself by changing its height and width. We need to calculate tile size, new tile size for the image size. Let In order to calculate, we just multiply by camera zoom original tile size, multiply by camera zoom, this camera zoom. Okay, now, and after that, put his tile size dimension sizes for width and height, the image. Tile size, tile size. And it's working. Oh, we just add additional parameters to the function draw image, and these two parameters affects image size. Let's create separate function for that. Um, Draw image with coordinates x, y, and size. Let's simplify a little bit the code. Okay, we create image and put here coordinates, offset image to draw, and the size of the image. Okay, it requires the type. Draw the image. Camera offset size. Make copy paste. So now we have working solution for zooming, and initial zooming is 0. As you see, picture size exceeds our screen. So what we can do about it, we can set initial zoom level by -2, for example, and also we can change zoom factor to scroll it slowly. We can even change it to 1 and 2, for example. And -4. Okay. Uh, Here is our picture. Here is our image, and we can move it. We can zoom it, but as you see, every time I zoom it, it's scaled based on its location of the top left coordinate is the same every time it's scaled. So it it doesn't depend on the position of mouse cursor. It's only depend on position on a left uh, top left corner. So and on the next step, we're going to fix it. We're going to change our zooming the way that it will be. Uh, it will be depend on our cursor. So this is it for step 3, and we are going to commit these changes. Okay, third step, commit. On the fourth step, we need to fix our zooming because now we can scale from top left corner, and we need to scale uh, by mouse cursor. That means when we scale, we want our cursor to be on the same location of the map. Or map coordinate, relative coordinate should be the same. Oh, how they do it? Let's explain it on a very simple picture as I try to explain as simple as possible. You see, here is a zoom level 1, our map, and we want to zoom it up to zoom level 2. Let's consider only x coordinate because we need all what we need is just to adjust offset of the second zoom level to change to find this second offset. We need to move this uh, move our image a little bit left. So in the, what we know about zoom level first? Zoom level first we have uh, x mouse coordinate that is constant equal first offset that we know x offset 1 plus x map coordinate that we don't know as well. When we zoom our map, zoom in or zoom out, it doesn't matter. We have the same formula, but in this formula we don't know second offset and second map coordinate. Offset and second map coordinate. But we don't need to know first map coordinate and second map coordinate. We only what we need to know is that uh, relationship between that.
So if we divide zoom map coordinate first to some map coordinate second, that will give us zoom delta. What is zoom delta? Zoom delta is a difference between two. This is actually zoom factor if you zoom in, and this is 1 divided by zoom factor if it's zoom out. So whether you have to multiply by zoom factor or you want to divide by zoom factor your image. So it's calculated. We find relatives, relationship between we found a relationship between these two variables, between maps coordinates. So now we need to do some take this three statement and find that our offset will might be calculated by this formula: x coordinate, x mouse coordinate minus x mouse coordinate minus x offset first, and divided by zoom delta. Not divided, actually multiplied by zoom delta. Okay, let me quickly fix it. Let me do ugly fix. Um, Here. Oops. Yeah, I know it's ugly, but what to do? It's multiplied by zoom delta. Here's our formula. We have to apply this formula for our x offset and our y offset. Okay, let's return to the code. We have camera offset, x, and first of all, we need to define zoom delta. What is zoom delta? Zoom delta. Zoom delta, this is math. Take zoom factor and raise it in raise it in power to to zoom direction. Yes, it will be our zoom delta. Now what we need is take this formula and use it for zoom x coordinate and zoom y coordinate. Let me just copy paste. Okay, and this is it. That is all fixed. You just need to know how to calculate properly when you zoom in by mouse cursor. And this is very simple formula. Let's check our application. It's reloading. Now move our map to the center. We move the cursor to the right top corner and start zooming. You see, location of the map is the same. Oh, here or here. That cursor always pointed to the same location on the map while you're zooming. Let's commit our changes. Step fourth. On the fifth step, we need to extend this map a little bit with tiles. Instead of one tile, I'm going to draw the whole map. But first, let's create the function that calls draw image tile that will draw image tile not by offset, but by coordinates, tile number and tile size. We needed to draw all the tiles in a cycle.
tile X. Okay, first is the image. Should go image. Uh, and now we copy that. Text. Text. Instead of offset X, we need to use tile X multiplying tile size. And the same here. Okay, we need to set styles. Oops. Okay, will be number, number, and number. Image. Okay, draw image. First we have image here. Um, Instead of camera offset Y, tile Y multiply tile size, and also specify width and height as a tile size. I'll copy paste, and now we have a function that draw the tile. So regardless the general the offset of the map. So here we can do, let's check this function that it works. I'll, instead of doing something like tilex like 0 and 0, draw image tile 0 0 tile size, first the image, this image. Okay, and but I didn't specify for draw image tile the general offset, camera offset. So in order to make it work, um, I I apply this offset on canvas context by translating. So not no yeah no now I'm not moving image coordinate to offset. I'm moving the whole canvas to particular offset. Let's check how it works. Okay, draw image. Okay, I need to remove all this because it's code duplication, and just draw image tile because I have only one image. And check is it working or not. Yeah, it's still working. Good. So I have 4 layers, and each layer has size. Size, I mean, in one dimension. This layer has size 2 because it's 2 in one dimension and 2 in another dimension. This layer has size 4, and etc. Let's specify layer size in order to later, in order to check uh, check my code with different layers and compare it with performance. Layer size, let it be 2. Now, instead of image, I'm not using one image anymore. I use multiply images. Instead of one image, we define layer that will be HTML image element as a matrix of HTML image element, and initial value is empty empty array. I need to fill this layer with images, and in order to do that, and in JUnit, I am create the cycle layer size. I need to push new image in this matrix. This layers define default value for first row in layer matrix, and here is we create another cycle. Size. Where we create images for each cell in the matrix. New new image. Okay, good. We have now for layers size 2, we have 4 images. For layer size 4, layer size 4, we have 16 images, and etc. For layer size 16, we have 256 images. And all these tiles are, I just want to remind that all tiles have original size 2048 pixels. So, okay, I populated this image, and now I have to draw it in cycle. And here, okay, tile size, we left that draw image. Here we can remove, okay, we just comment it, might be useful. Uh, Here, instead of draw image tile, we create the cycle. Do it like that. Double cycle, I would say. And we put here draw image. Draw image. Instead of image, we here put layers. We take image flow from layer. But it's not enough. We also have to specify source, and source will be also depends on layer size. Um, okay, constant image equal variable, and then go add source to the image. Yeah, I want to remind about another thing is once we assign the source to the image, it automatically starts loading. So we need to check. First, we need to check that source is already assigned. Image. If not image source, then image source should be equal. Okay, here we change the string, add the variables, layer size, layer size, and here we change it to E and G. Cool. So what else? We draw tile. Okay, we added context translate offset. So this tile is drawing regardless that general offset. Draw image. Okay, we can remove this function because we don't need this anymore. We don't need this because it used already. Draw image tile and from parameter. Okay, we just during in this function we automatically coordinate for each tile, uh, not considering the general offset. Okay, I think it should work. Let's see. No, it doesn't work. I see only last tile. I need 1, 2, 3, 4. Okay, I need to replace that tile X. I forgot to replace this hard-coded value in draw image. Okay, and we have a map. We have our first layer consists of 4 big images. Yes, and as you see, it works very fast, zooming and panning, but the quality is very bad because it's only first low quality layer. Okay, let's try different layer size. 16. It will give us 256 tiles. So now it's lagging a lot. When I pan, when I zoom, and you see I have to wait several seconds because when browser resize a high resolution picture, it actually consumes a lot of resources, and resources are limited. When I zoom in and palm in, it's lagging. It's not that good. Okay, this is it. Let's return to our layer 2 and zoom 5 -5, for example. Okay, and this is our result. Now we have the whole map. We can set any layer, and the next step we're going to add layers dynamically.
Let's commit our fifth step and move on to the sixth step. Fifth step. Okay. First of all, I want to show you some bug. You see here is the line between tiles. We need to remove it. This happens because tile have to round it. Position of the tile have to be rounded, and they don't really fit to each other very well at the edge. So we need to round something in the code. Tile size, I think tile size we have to run because camera zoom might be flawed and tile size might be not integer, and it gives us such kind of picture, not a very good fit to each other. Floor, let's see, and you have this bug anyway. So in current implementation we have only one layer here, and we need to create several layers and switch between them depending on the zoom level. We have layer size, fixed layer size, but instead of this, let's create enum, numeric enum, layer size. Uh, let's create layers, interface, type layers. So we don't need layer size anymore. Uh, let's define, instead of layer, let's define layers. That will be e layers, and let's set initial value to our layers. So in this particular, okay, maybe we need to set some initial, okay, layer size. We need layer size. Anyway, we have to define default layer size. Layer size. Size equal, let it be 2. Uh, so now we need push image objects for to all layers. So what we do, we just create a function push images that push images but in particular layer, and then in ngo init we run this function for each um, layer. So this way we populate all the layers. This comment we can remove already. We don't need them anymore. Now we have to draw tile layer size. Here we are going to this layer size, this layer size. We have a variable that will be changed according to zooming, and we draw image dot layer, this layers, create layer size, and here we also take layers layer size. Yeah, it should work. We are not changing it right now, so just check it. Let's check with that by default we've opened for we should open the first layer. Okay, let's check inspect and see.
I'll open network console and see that we downloading only 4 images here. Yeah, we have 4 images. Let's switch to the next layer size here by changing default layer size 4, for example. Check is it working? Not. Yeah, it's working. You see, more images were downloaded because we changed default layer size. Not now we have to switch this layer size depending on zooming. So what we do for that is we need to add logic on scrolling. So when just after we define zoom level, we need additional logic to change layer size. And we need to adjust our scaling when we switch to the next layer site. We have to see image with the same we have to see canvas with the same size, so we have to adjust the layer, so by dividing by 2 every time we switch the next layer when we zoom in, and vice versa, multiply by 2 when we switch layer by zoom out. So how we do that, we change uh, tile size. We have to change camera zoom. Yeah, I have to switch this. Mm, this camera zoom. Yeah, actually, we can move this camera zoom here, and const. We don't need we don't need camera zoom to be a class attribute. Camera zoom, bow. Yeah, camera zoom. So every time we draw, we calculate camera zoom, uh, taking zoom factor and raise it to power in power to the zoom level. Now we have to adjust it when we switch layer, and divide it by layer size. Okay, okay. This is necessary again. This is necessary layer size. This is necessary because different layers have different sizes. Next layer will be 2 times less, I mean 2 times more in sizes than the previous one. Okay, 1.5, zoom -3 and 6. Oops, -3, 6. I just copy paste from what I already implemented. Anyway, and we have to set default layer this default layer size, return it back to 2. Well, we have 4 images downloaded. Let's try to zoom. I can't zoom. I just can't zoom. Haha, default zoom level -5. It's less than -3. That's why I can zoom in, zoom out
Yeah, because of this condition, yeah, this condition always return the exit the function on scrolling, so that's why I can't zoom. We need set default zooming in range of -3 and 6. Let's set minimum zoom. And yeah, see, 4 images are downloaded. Now we zoom and we have second layer with 16 images. We zoom, okay, let's zoom to this island, for example, more and more and more. And we have 64 images downloaded for the third layer. Let's zoom this island, for example, or this town. Yeah, and now we downloaded 256 images. Okay, so uh, we need to improve performance because we don't need to download all the images. We only for the layers we only want to download images that is in viewport that you see on the screen. If you implement images in HTML in a declarative way, you have a special attribute for image tag called loading lazy, and it provides you that feature from the box. But on Canvas, I have to implement it myself. I have to specify what exactly images I have to draw, what are images I see right now in viewport, and draw only them when I switch the layer or when I pan the image. Okay. It already works faster because all images downloaded. And when I zoom out, browser don't need to resize the high resolution picture. It switch layer with lower resolution pictures and resize it. That's why it works much faster. But anyway, we have to implement logic to not download the whole images at once for each layer every time we switch zoom level. Let's implement this logic and see how it works. So here is the code that responsible for downloading the whole images. When we set image source, we download it automatically. So we need to specify the ranges of the images we want to download. In order to do that, we just set special formula, tile x and tile minimum visible tile x, minimum visible tile y, and etc. Here, okay, -1. We don't need -1 actually, because it's condition, strict condition. Tile. I will explain a little bit. Let me change the code. I will explain a little bit later what I'm doing. Okay, here is for minimum x, visible x tile coordinate. Tile coordinate is not that absolute coordinate for the viewport coordinate. Tile coordinate is a number of tile. For example, if you have second tile, tile x will be equal 1. If you have first tile, tile x will be equal 0. So how to calculate what tiles are visible? So I just take camera offset divided by tile size. That's way I get the tile number, minimum tile number that is visible. And for maximum, I use the difference between width of size of the viewport and the camera offset, and also divided by tile size. That's how I get maximum visible coordinate, maximum visible tile number. And then I round it
and that I take minimum between layer size and yeah, between layer size and this number. Okay, we have here some problem. Okay, it doesn't work. Okay, minimum maximum x minimum y maximum y. Okay, okay, now I see it. Okay, it's not really because okay, got it, got it. It's because it's rounding. We need to do it again. -1. Have to put -1 here, and we have to put uh, less or equal. This way it will work. Cool. So let's see. Network tab, you see 4 images downloaded. Now you move in, zoom in. Have not there is not all the images downloaded from the second layer, only 6 images. So and when I pan, new images download, and you see seventh and eighth image downloaded, and when more and more images download from second layer as I pan. So let's switch to the next layer by zoom in, and we have only 5 images downloaded for third layer, and when I pan it, see that new images downloaded from the third layer, and etc. So it works like a charm now. Okay, so it works. We implement in this step we implementing switching between different layers. We implemented also lazy loading. This is it. Let's commit our result. Sixth step. So it's up to you to decide in what zoom level you have to switch layer. So this is most convenient to you. I have some hard-coded value here. You see zoom level 4, zoom level 2, zoom level -1, but you can adjust it as you wish, or make it some, or even invent some formula that will depend on layer size, real layer size. In my code, it's just hard-coded values. Commit.